All right, so where we're going to start this semester is talking about units of measurement. And so a couple just basic definitions walking through on this first slide here is the first thing we can talk about is a physical quantity. And so these are the variables that we'll care about. Often they're the things that we're going to end up solving for within a problem, right? So distance is an example of a physical quantity. Well, once I've decided what physical quantity I have, I can think about that quantity's dimensions. Distance has dimensions of length. So the dimensions is telling me sort of fundamentally about what am I keeping track of with that physical quantity. And then for each dimension, there are actually multiple units. So for length, again, if we've got short lengths, we might give a short length in inches or maybe feet or maybe even yards. Longer lengths we might give in miles. Or we've got a whole nother set of, hey, we can give short lengths in millimeters or centimeters and longer lengths in meters and kilometers. And so you notice that there are a lot of different units that all have the same dimension. So at the end of the day, a lot of times the physical quantity and the dimensions will end up being the same. Distance is sort of an example where that's a physical quantity where the dimension is something different. But often when we'll talk about most other physical quantities, such as, say, force or energy, will have dimensions of force or energy. So usually these two things are the same. Then we got a lot of choices when it comes to units. So what we want to keep, or what we care about then, is what type of unit, what system of units are we using. And again, here what you see is there are two basic systems that we're using to describe length. So the inch, feet, yard, mile, those are all imperial, US customary, British, English, all those are sort of saying the same thing. Millimeter, centimeter, meter, kilometer, these are all metric units. And so of course we're going to end up using metric units. We'll want to be able to convert from English or US units into metric units to do our calculations. Now, even within the metric system, there are still a couple of different systems of units that you could use. Those of you who've taken chemistry have probably used the CGS system a lot, where you talk about lengths in centimeters, masses in grams, and time in seconds. Another option is you can do lengths in meters, masses in kilograms, and time in seconds. This system is known as the SI, or International Standard System, and that's actually the one that we're going to use almost all the time in physics. So we're going to basically confine ourselves to working problems within SI units. Now, within the metric system, we know that we can go back and forth between metric units, and what makes the metric system so easy is that different units are basically just all, they're multiples of powers of 10. So notice that this chart, scientific notation here tells us this is 10 multiplied by itself 3 times, this is 10 multiplied by itself 6 times. So these things are all getting bigger with the positive powers. 10 to the negative 2 is another way of saying 1 divided by 10 squared. 10 to the negative 3 is 1 divided by 10 cubed, or 1 divided by 1,000. So these things are all getting smaller with the negative exponent. And so what I see is this table is sort of divided in half, where I've got larger than 1 units up here with positive exponents, smaller than 1 units down here with negative exponents. And so you might talk about a kilobyte is 1,000 bytes. Right? A megabyte is 1,000,000 bytes. A gigabyte is 1,000,000,000 bytes. A terabyte is 1,000,000,000,000 bytes. So these are all things that are getting bigger and bigger and bigger as you go up. These are all getting smaller and smaller and smaller. So you go from centa to milli, you go from 100th to 1,000,000th to 100 to 1,000th to 1,000,000th to 1,000,000,000th to 1,000,000,000,000th. So these things all get smaller as you go down. And so the way you want to read off this table is basically it's giving you an equivalent relation. So if I want to think about PM, so the first thing this is telling me is M is my base unit meter. The P in front is for the pico abbreviation, so this is 1 picometer, equals 1 times, and then I'm just going to pluck this out, so 1 times 10 to the minus 12 meters. Another way of saying this is that a picometer is 1 trillionth of a meter. Going the other way, well, here this capital W happens to be watt. It's a unit of power. And so here this says I've got 1 mega, a capital M abbreviation mega, 1 megawatt is equal to 1 times 10 to the positive 6 watts. So that means I need 1,000,000 watts to make 1 megawatt. So this is the way that we'll use this table to figure out equivalency relations within the metric system. Now we talked about our base unit system. We're going to use SI units. And so basically everything in the SI unit is based off 7 what are known as base units. So length, mass, time, MKS, meter, kilogram, second. And then the other 4 base units are temperature, electric current, amount of substance, and luminous intensity. Now, amount of substance we'll run into towards the end of the semester. You've probably already seen in chemistry classes dealing with the ideal gas law. Electric current we're going to save until second semester of the course. We'll deal with temperature later in the class, so later this semester. So we'll see almost all of these over the 2 semesters that you're going to end up taking physics. And the nice thing about this is that we can build every other SI units for all the other physical quantities out of these 7 base units. So one of the things that we'll get good at are creating what are known as derived units. And derived units is just another way of saying what's the unit of something that's not a base unit. And the one thing that we'll take advantage of in deriving units is that units follow the rules of algebra. So if I've got 1 unit divided by another, they'll cancel. If I've got a unit times a unit that are the same thing, I'll have that unit squared. So we're going to take advantage of the rules of algebra in dealing with units, and then we're going to use equations for physical quantities to derive our new units for some new quantity. So as an example, here I've got an equation that says the area is base times height. Notationally, when I take my quantity and put it in brackets, I want to read this as the units of, or the dimensions of area are dimensions of length times, or units of length times units of length. So here I've got area is length times length. Well, the SI unit for length is meters, so this means area is meter times meter. That's just meter squared. So the SI unit for area, meter squared. Similarly, same idea. I've got an equation that tells me that speed is just distance divided by time. So the units of speed are going to be the units of length divided by the units of time. Units of length, meters, units of time, seconds. So meters per second is my unit of speed. And so we'll get hopefully fairly comfortable fairly fast with figuring out what derived units we are, or we're dealing with, by using an equation to basically calculate out what our new unit is.